Hey guys, welcome to episode 6 where we are going to talk about player movement. So right now this is the actual game cave story, and we're going to kind of look at how he does movement in the game because this is the best way to visualize it. So I'm going to describe it, show it in detail. So first of all, here's Quote just standing there. Now if I press left, he starts to move slowly to the left. He's walking into a wall, and he'll keep on walking. And I'm still holding left, and I let go, and he stops walking immediately. So as I go to the right, by pressing the right arrow, he's going to slowly kind of work up to his max velocity. And you can kind of see that. You can really see it if you just kind of tap the left arrow key. You'll see he barely moves or doesn't move at all. But he'll start his walk animation, and that's because he's working up to his full speed. And the other thing is, when you let go, he'll stand and kind of slide for a bit. So see, he's standing and he's sliding, and he goes to a standing animation or lack of animation as soon as I let go of an arrow key. And what happens if I press both left and right at the same time? Well, nothing's happening. But if I let go of left, then he starts moving right. And if I let go of right, then he starts moving left. So, yeah, that's, I think, all we're going to get into for this episode. So let's talk about how we're going to make Quote walk left and right. We're going to use left arrow and right arrow for movement. And just as a recap, when left is pushed, Quote faces left, then he accelerates left. When it's held, he accelerates left, but he does not exceed a maximum horizontal speed. And then when it's released, Quote decelerates to the left until velocity is 0. Similarly for right. And when they're both pushed, left and right are both pushed at the same time, Quote doesn't move. So there's really two problems. Which way is Quote facing? And we're not going to solve this in this video. And where on the screen is Quote being drawn? And we are going to solve this one in this video. So let's talk about the solution. We're going to introduce a player class. It's going to have a sprite, an X, Y, velocity X. Velocity Y will come later, but we'll get there. It's also going to have a start moving left, start moving right, stop moving, and these are just going to be called by our input handling part of the code. Again, no movements are going to take place in the input handling code. It's all going to be in the update method, which we need for our player class, and then it will be shown in the draw method. So let's talk about the equations for walking, and these are paraphrased from physics. We're going to update x first by the velocity times time, and then we'll update the velocity by acceleration times time. And this normally has an acceleration component 1/2 at squared, but we're not going to worry about that because it just adds complexity and it's really a negligible effect. So acceleration x is based on whether he's walking left or to the right, and it's going to be negative walking acceleration, which is some constant if he's going to the left, and walking acceleration if he's going to the right. Velocity x also varies based on Quote state. If he's walking, I've already given that equation here, it's velocity x plus equals acceleration times time. And then standing, we have a new equation that's not really from physics, but it turns out to work out really well and look really nice. So it's just take the velocity and divide it by some constant that's greater than 1, and we're going to use probably something around 1.2, so you get the idea. So just velocity dwindles down that way. Alright, let's get started. Let's start by making our player class and just have it contain the sprite from the game class that we have in the game class right now. So we'll edit new class, header guards, and struct player. So this will have inside of it our scoped pointer to our sprite. So boost scoped pointer to sprite. For declare sprite, and make sure to include boost. Let's see, anything else? We'll give our player a starting X and Y. In the constructor. And we'll store those in member data. Let's open up corresponding CC file and define our constructor. So that's going to be player we'll set x to be equal to x. Oh, no, we'll do that in here. X to be x and y to be y, because why not? And then we want to initialize our sprite. So we'll do sprite dot reset new sprite, new animated sprite. Oh, let's go ahead and grab this from, we'll grab that from the game CC file where we already have it defined. A couple things more we need, since we have our sprite which has an update function. We need an update function for us, and this will take int elapsed time milliseconds, and draw, of course, which will have just the graphics because we as the player supply the x and y. Let's fill these in. Player and since sprite update elapsed time milliseconds and draw, giving it graphics and x and y. I think that's almost everything. We still got to get the new animated sprite definition from in here, so I'll just take this for now and just plop it right in there. Of course, we need to now scope our k-tile size and include game.h. Alright, so that's our player class. Now let's get rid of this sprite inside of our game H and replace it with a player. So we'll make this player pretty easily like this. Animated sprite, no, we just need a player now. I'll need to include some more stuff in player, I believe, but we'll figure that out when we try compiling. And so we'll do player.reset, and this will be a new player, and we'll dump him at 320 by 240, which is just arbitrary, but it's the center of the screen. For our update method, we'll just do player update instead of sprites, so it's player, and then player draw, and we no longer pass in the 320 by 240 because player holds onto that data. Let's see, player draw gets updated, drawn. What else do we need? I don't know, so I'm gonna go ahead and make lots, a big wall of errors. Let's start at, I gotta include inside of player.cc a sprite.h and probably animated sprite too. I don't know if I need both though, so let's see if this compiles. It doesn't yet. File application. An instantiation of member function, boost sprite. Well, we also need graphics in here, that's for sure. But we need to forward declare graphics. To an incomplete type sprite. Note, in instantiation of member function boost scoped requested here inside of struct player. Maybe we need to actually include sprite in here. Let's see if this does it. Yeah, and that was it. Really, that was it. We needed to include sprite in the header file. Alright, so now it makes. Now let's try to make running. And quote is still walking, so we're still good. Okay, now let's jump into our player class so that we can create and flesh out our input handling functions for the player. So start moving left was one, start moving right was another, and then stop moving. And so we fill these out like so. Maybe that'll work. Dang. Okay, so let's record this. Word, player, end, down, Q, repeat, repeat. Okay. So what did I say start moving left was going to do? So what's going to happen when we start moving left is, actually let me open up the slides so we can look at what I said. So when quote starts walking left, his acceleration x is going to be the negative walking acceleration. And if he starts walking right, it's going to be the positive walking acceleration. So we need to give quote an acceleration x, and we need to set that acceleration x to be equal to negative k walking acceleration when we start moving left, and we want it to be positive k walking acceleration when we move right. And then when we stop moving, of course, we're going to, actually not of course, we are going to set it to 0.0f, and that's because we aren't going to use the acceleration when we actually calculate the velocity slowdown for when we stop walking. So we're going to, when we say stop moving, we're going to set acceleration to 0.0f. Let's compile. That means we need to define our constant namespace. Const for k walking acceleration equals 0.1f. I don't know if that's right. I'm going to have to experiment with that and find out, and then I'll let you guys know a better value. Let's see. Okay, so this all looks good. Now let's head back to the game class and call these functions. And so, just as a quick recap, if both are being pressed, both left and right, then stop moving. Otherwise, if it's left, move left, start moving left. Otherwise, if right, I'll put else. Then start moving right. And then otherwise, again, stop moving. So there's two cases where we stop moving, and that's if both left and right are being pressed, or neither left nor right are being pressed. And we could capture that in an additional check inside of here, but I think this is just easier to look at. So if both left and right are being pressed, so if input.isKeyHeld SDLK left and input.isKeyHeld SDLK right, then we want to stop moving. And that's player stop moving. Otherwise, if it's just input dot, if it's just left that's being held, we'll start moving left. One more. And finally, stop moving otherwise. Let's make. Okay, that works. So we'll run it, but nothing should happen. Yeah, I'm pressing left and right, nothing's happening. That's because we're not actually updating his position yet. So let's do that next. So let's jump into our player update method so that we can implement our physics. Let's see. So our first physics equations was update x by velocity of x. And it's not auto-completing because I have yet to define velocity. And velocity is just going to be a floating point. We'll put it here above acceleration, velocity x. And let's also make sure that we initialize it here in our constructor, 0.0f, and acceleration x should also be 0.0f to start. So x plus equals velocity x times elapsed time in milliseconds. And since velocity x is a floating point number and x is an integer, instead of truncating, we need it to round. Otherwise, we'll get some weird effects when we go, like it'll look different when we go left versus when we go right. And so let's include CMath in order to get that round function. So x plus equal round, velocity of x plus equals acceleration x times the elapsed time in milliseconds. And since both velocity and acceleration are floating points, we should be fine there. Okay, but we're not done here. We've got our physics equations, but we also need to implement a max speed, terminal velocity, if you will. So this is going to be defined by a constant. So let's go up to our constants. And by the way, I found my acceleration constant, and that is 0.0012. And I don't know if this is the exact value, but I just kind of played around for a little bit, and this seemed like a good value to me. So that's what I'm going to use here. And we also need a k max speed x, and this is just going to be positive 0.325 f. And I'm going to put the units on here. So this is for the acceleration. It's going to be in pixels per millisecond per millisecond. And so if you want to reason about how many pixels it should be moving, this is to help you do it more mathematically. And the max speed is going to be in pixels per millisecond. We'll need one more constant while we're up here, and that's going to be const float k slowdown factor. And this is the slowdown factor I was talking about when quote stops walking, when he's been walking and he stops walking and his velocity slows down at a sort of exponential logarithmic. I don't know the math, but it slows down. And that's what we're going to use. And so let's go back down to our update method. And inside of our update method, we want to handle 3 different cases of acceleration. So if he's accelerating to the left, or if acceleration x is less than 0. Otherwise, if acceleration to the right, greater than 0. Otherwise, it's equal to 0. And these are actually, should be floating point values. Let me just change that. Okay, yeah. So for the first case, we want to say the velocity x, we want to say the velocity x is equal to the maximum of the velocity x versus the negative k max speed. And so this way, we don't ever go below negative k max speed. So same kind of logic and reasoning for acceleration x greater than 0, except that instead of negative k max speed, it's positive k max speed, and instead of the maximum, it's the minimum. And then finally, we are going to use our slowdown factor here in the else case, and that's going to be times equals k slowdown factor. So yeah, I think that's all I'm going to try making. Okay, so it built successfully. Let's see if there's, let me think if there's anything else. I don't think so, so I'm going to go ahead and try it. Let's try it. Alright, here we are. So I will press left really quickly. He moves left a little bit. Press right really quickly. He moves right a little bit. So let's hold down. Accelerates to the left. Slows down. Sweet. So hold right, release. Slow down. Cool. You might notice that you definitely should notice that there's like some pixels, like remnants, and you're like, what is this weird crap? Or you know what this weird crap is, and it is because we are drawing to the SCL buffer, and it doesn't get cleared automatically. We have to clear it ourselves. So let's go ahead and make a method in our graphics class to do that. So let's do void graphics, and we'll just call it clear. And we'll declare it up here. And what we're going to use is SDL fill rect. And what this takes in is a SDL surface and SDL rect pointer, as well as a uint 32 for color. And this is the destination rect, and this is the surface that we are going to fill in. So this surface is going to be our screen. This destination rectangle. Now we could make a destination rectangle that took up the whole screen, but as a convenience, null means that you want it to take up the whole screen. So let's just use null. We'll just kind of leave that in as a note to ourselves. And this uint32 is color, and they're mapping functions to take an RGB value and turn it into a proper color. But since we're just going to use black, we can just use 0, and that's easier than calling in an additional function. Alright, so this is all we need in our graphics class, but let's head into our game class and actually call clear. And that is done in the draw method of game before we start drawing. So graphics.clear, and that'll clear out the buffer that we are about to draw to. And then once we flip it, it'll all look better. So let me go ahead and make. It looks good. Let's try it out. Alright, so no more particles or artifacts left over. So As you can see, Quote's walking, and it looks fine, except that Quote is walking while he's standing, and he's walking to the left, which that actually looks right, but when he's walking to the right, that's kind of a moonwalk, and we really want him to face the other way. So in the next episode, we'll look at getting multiple sprite sheets and switching between them properly. Alright, thanks.